Here we go again, another PowerPoint recording. Hopefully this time I can try and not blow your ears out with my incredibly spontaneous loud outbursts of talking volume every time I click to a new slide and say so. So there I go, I did it already, fail. Getting pretty close to rounding off Unit 3 now really. So in terms of this topic, that the things that go together pretty well, we've talked about our acute responses to exercise. We've talked about our energy systems and how we really synthesize ATP. We've also talked about our fatiguing mechanisms relevant to each energy system. And today we're going to look at some of our recovery strategies. Specifically in terms of our key knowledge, we're going to look at passive and active recovery methods to assist in returning the body to pre-exercise levels. So comparing passive and active recovery, and also having a look at some of the things that come under each of those labels. A good recovery is crucial, and unfortunately by the time you finish a pretty solid exercise bout or a game of sport, often the recovery, unless you're playing at a pretty high level where it's quite regulated by your trainers, if it's left up to you, a lot of people do ease up on the recovery, but it is important that you do as good a job on your recovery as what you do in your actual performance, so then you can perform at a high level again next time. And later on in Unit 4, we'll look at some strategies you can use to enhance recovery as well. So the aim of recovery is to return the body to pre-exercise conditions, and also to reduce the effects of fatigue in doing so. And if you don't have a good recovery, what you're going to do is you're going to delay getting rid of the byproducts that you've produced during exercise. You may also get to the point of overtraining, and you could get some overuse injuries or even some immunodeficiency illnesses at its worst. So recovery is really important. I can think of some sporting teams I've been involved in the past where you'll play a pretty solid game of footy, and your idea of recovery is to go into the sheds and rehydrate with a few drinks that probably weren't the most effective choice. That is not what you do. That is a good way to take a long time to recover. What you do is you target the things in your recovery that have fatigued you in the first place. So we'll look at how we can target refueling to deal with fuel depletion, how we can get rid of metabolic byproducts that have been a factor of causing fatigue, how we can address some of the neuromuscular factors, and how we can tackle some of the factors associated with thermoregulation in terms of exercise causing an increase in body temperature, dehydration, that sort of thing. If we tackle the concept, the fatiguing mechanism of fuel depletion, if you remember back, we looked at fuel depletion in terms of phosphocreatine, and then after that we can look at fuel depletion in terms of glycogen stores. But if we look at phosphocreatine depletion, obviously this occurs when we're working at really short but high intensity exercise bouts using our ATP PC system. The best way to refuel your phosphocreatine levels is from a passive recovery. And a passive recovery means that you're not doing anything. So at the end of your exercise bout, you're either doing incredibly low intensity exercise that doesn't call upon the PC system, or you're not doing any exercise at all. You're standing still, or you're slowly walking, whatever it might be. And passive recovery is only really the best option when we are talking about refueling phosphocreatine levels. If you're recovering from anaerobic glycolysis when it's your predominant system, or even aerobic energy system, passive recovery is not as effective as an active one. So we've run our 100 meter sprint, for example. Our PC stores have been depleted. How do we refuel them so we can use them again? So first of all, we stop and we don't do anything. We rest. Passive recovery. Our PC is restored incredibly quickly. You can see by this point here, it says it's restored in the rapid part of oxygen debt. We're going to talk a bit about oxygen debt in our next series of slides when we talk about oxygen deficit steady state and oxygen debt. So we can restore our PC from two sources. The liver produces phosphocreatine from amino acids, and we also get dietary creatine when we eat food. Obviously, if we're looking at our figures down the bottom here, which are pretty impressive, within 30 seconds you've got your phosphocreatine stores back up to 70%, and within 3 minutes you got your phosphocreatine stores back up to 98%, which is so close to 100%. After 3 minutes you're ready to go again, high intensity, as hard as you did the first time. Clearly you're going to do a pretty rough job restoring those fuels by eating a steak straight after you finish exercise. So what's happening to refuel your PC stores so quickly is probably this first one here where your liver's producing them. So conditions required, you need to have an appropriate pH level with appropriate supply of oxygen. You need to be a passive recovery, and with those things you will refuel your PC stores pretty quickly. Still on the topic of fuel depletion, if we're looking at muscle glycogen or blood glucose being the factor that has caused fatigue, obviously we're now moving into the aerobic energy system that we would be using at that time. And unlike the ATP PC system and refueling phosphocreatine levels, because the body doesn't make glucose itself, we can't refill our glucose levels and our glycogen levels as quickly as what we could our phosphocreatine levels. So it is definitely going to take a lot longer. Firstly, prevention is better than cure. So having a good carb-heavy diet before an event will help you to ensure that you've actually got adequate stores of glycogen and blood glucose before your event, which should help minimize the amount of them you need to restock after the event. But other things that can help is taking glucose into your body during your events or during your training or your competition. And best way to do that is through a hypertonic sports drink, which would have a high sugar content. Immediately after your event, to help restore your muscle glycogen and your blood glucose stores, what you want to do is you want to eat some high GI foods. So they're our ones that release glucose quickly into the blood, and you want to consume them as soon as you can after the event. If you look down on this table here, when you consume adequate glucose or glycogen within the first hour of ceasing activity, within 5 hours you'll have 55% of your glycogen stores restored, and within a day, 24 hours, you'll have them at 100%. If you delay your consumption of glucose until 1 to 2 hours after the event, it's going to take double the time, up to 2 days, to restock to 100%. And if you delay for 5 hours, it's going to take you up to 5 days to get them back to pre-exercise levels. Moving on from fuel depletion as a fatiguing factor into metabolic byproducts as our fatiguing factor now. So you've just had a hard exercise bout. We've been working at max intensity for greater than 10 seconds. So you're using your anaerobic glycolysis system predominantly, and causing your fatigue by using that system, as you know, is a production of hydrogen ions. So immediately after the event, what your recovery wants to do is it wants to flush out those hydrogen ions and get rid of them. And the quicker you can get rid of your hydrogen ions, the more quickly you can recover, and the more quickly you can then perform again at that same high intensity. This is where we look at our active recovery. So active recovery is essentially when you're doing similar movements to what you did in the event in the first place, but at a much lower intensity. So if you've just run a 400 like we did in class the other day, and you've run your guts out and you've stopped, and then I've gone, hey, let's go for a little jog down the end of the field and back, and you've thought, Weber, you're a moron, what are you making us do this for? Well, the point is the active recovery is going to double the time, or halve the time it takes for you to recover. So active recovery is pretty easy. You just need to be active, but at a low intensity. Why would you do it? It's not just to cause pain as you've finished your event, and some of you are probably thinking, well, if it halves the time, maybe it's worth just being sore for that extra hour and not having to move straight after the event. But that's certainly not the best thing to do. So if we do an active recovery, firstly, you're going to keep your transport of oxygen to your working muscles at a higher level. And that is good because oxygen is required at the muscles for you to actually be able to remove the hydrogen ions. You're also going to create a muscle pump. So by your muscles contracting and pushing on your veins, you're going to increase blood supply back to the heart, and that's going to help you to get rid of the hydrogen ions out of your system and also help increase oxygen supply to the muscles. Still on that idea of the muscle pump, it's going to prevent venous pooling around your muscles. So obviously while you're exercising, you've got a high blood flow to your muscles, and then suddenly you stop. That blood doesn't just disappear, it hangs around your muscles. So if you're active, your muscles are still squeezing your veins and getting that blood from your muscles back to your heart to be redirected around the body. If you just stop still, like a passive recovery, the blood's going to pool around your muscles. Another method, this is not actually an active method, it's a passive method, but contrast bathing, where you're taking those hot bath, cold bath, causes your muscles to sort of relax and contract, and that works to increase blood flow to them and help get more oxygen to remove the hydrogen ions as well. So to finish this off, down the bottom you can see passive recovery compared to an active recovery. The active will halve your recovery time. Recovering, targeting your neuromuscular factors of fatigue is pretty great, really. It says the only thing you can do is rest and drink a few sports drinks, which is not too bad. The point of that being, you need to replace electrolytes, which are important for your immune system to function. Those of you that are pretty familiar with action potentials and how neurons work, you'll be able to know how important sodium, potassium, and calcium all are to help that process to occur. So neuromuscular factors, passive recovery, rest, and restock your electrolytes. If you've become fatigued from thermoregulation, increased body temperature, or dehydration, your recovery methods directly target those two things. So if you've got a level of dehydration, clearly it's important to rehydrate after you finish the event. Preferably you'd be hydrating during your event and decently hydrated before it to avoid any problems. If you've become fatigued from an increased body temperature, and therefore that would have increased blood flow to your skin, decreased blood flow to your muscles, so you would have had an effect in your performance, hence fatigue, you need to cool down. You can look at this two ways: cooling down after an event completely to get back to normal body temperature as quickly as possible, or also some of these strategies could be used to cool down if you're doing an event that does have breaks between sets or halves or quarters where you're getting pretty hot. Homeostasis is the word we use when we sort of say the body regulates its internal environment within pretty narrow limits. Temperature is definitely one of those things. So roughly 37 degrees Celsius is your body temperature, and your body doesn't like to go too far above or below that. So if we're addressing an increase in temperature, things we're going to do to cool down, we could do some contrast water therapy, which is, the hot and cold bathing. You could certainly wear ice vests at the end of an activity or between sets. You could go into a cool room. You could have fans on the side of the field or the court, wherever you're playing. Activity being conducted under shade, and also having modified clothing or suitable sports clothing where you can sweat. The sweat can evaporate, because at the end of the day, evaporation is the biggest thing that cools us down. All of those things will help you maintain appropriate body temperature.